In the previous video, we have completed question number B2, 1B2. Now we will solve and verify the identity of question number 3, that is A union C complement equals A complement intersection C complement. Before verifying this, we have to find out the value for A union B and A union B complement. That is, A is given by the set of integers x belongs to z such that x belongs to z such that 0 less equals x less equals 10, and C is the integers set of integers given by x belongs to z such that x is greater or equal to 5. Now, by the definition of union, A union C will be equals to set of integers x belongs to z such that x greater equals 0, because by the definition of union, A union C will contain the elements of either A or C, that is greater than equals 0 to 5 is or are in A, and after that is greater than or equal to 5 are in C, and therefore the elements which are greater or equals 0 will be in C. And here is the universal set. We can take the universal set as Z, and therefore A union C complement will be x belongs to Z such that x less than 0, because note that we have seen that sets A, B, C and D are all subsets of the set of integers of the set of integers z, that is z, of the set of integers, that is z. Okay, and hence z is the universal set here. Okay, keeping this in mind, we will find out the right hand side, that is A complement. A complement will be keeping this note in mind. We will find the value of the right hand side, that is a complement will be the elements of z, that is the integers x belongs to z which are not in a, that is minus infinity less than x less than 0 and above the integer 10, that is 10 less than x less than plus infinity. And C complement has the integers x belongs to z such that x is less than 5, that is we can say that minus infinity less than x less than 5, and therefore a complement intersection C complement will be the set of elements, that is the set of integers such that which are both in A complement as well as in C complement, that is the elements minus infinity less than x less than 0. This is the value for A complement and C complement intersection C complement, that is it can be written as x belongs to z, it can also be written as x less than 0, and therefore from 1 and 2 we can easily verify that the LHS and the required RHS, that is from 1 and 2 we can say that A union C complement equals A complement intersection C complement. Now only one question left here, and we will continue this in this video after erasing this, that is question number 4 1b4 of exercise 1, which we have to verify that A intersection D complement equals A complement union D complement. Now as we know that A is the set of integers x belongs to z such that 0 less equals x less equals 10, and D is the integers, D is the set of integers x belongs to z such that x less equals 15, and therefore A intersection D will be the set of integers which are in both A as well as in D, such that 0 less equals x less equals 10. We can also verify that here it is clear that A is subset of the set D, and therefore by the consistency property we can easily say that A intersection D will be equals to A intersection D will be equals to A by the consistency property, Now we avoid here. You can also follow these steps to find out which is equals to A, to find out the value for A of the LHS. This property is known as the consistency property. Consistency property. Now therefore A intersection D complement will be equal to A complement, and which is again the set of integers x belongs to Z such that minus infinity less than x less than 0 and 10 less than x less than plus infinity. And the set A complement has the elements, that is the set of integers x belongs to Z such that minus infinity less than x less than 0 and 10 less than x less than plus infinity. And the set D complement has the elements x belongs to Z such that which are not greater than or equal to 15, that is which are not less than equal to 15, that is x belongs to Z such that x is greater than 15, and therefore A complement union D complement will have the elements A complement union D complement will have the elements x belongs to set of integers Z such that minus infinity less than x less than infinity and 10 less than x less than plus infinity. Why? Because we have clearly seen that T complement is also a subset of A complement. Therefore, using this property, again we can directly write it as A complement, and therefore from 1 and 2 we can say that A complement, we can say that A is not A complement. A intersection D whole complement equals A complement union D complement. Therefore, we have complete the verification of the identity A intersection D complement equals A complement union D complement. Now we will solve question number 2 in the next video. Thank you.